So I wanted to start with the question of how the concept of flexible electronics is changing, or as the case may be, expanding over time. And to get into it, I wanted to go to you, Art, first to respond.
Yeah, there's a lot going on, and part of it is that um, one of the things that's always fascinated me about this technology is the just huge variety of application spaces, and you're starting to see it show up in a lot of them. There's consumer electronics that are showing up with electronics in it that are hybrid in nature, and basically, I think of hybrid as anything that's additive. So it can be including additive interconnects where you wouldn't normally see that. But one of the other things that's also kind of challenging about this whole thing is many people are using this technology for specific applications. Maybe it's an interconnect, maybe it's a die attach, maybe it's something like that. And it's not like they go out and advertise that it's in there. So hunting down the people who are applying this technology so that we can share that out with our community is a big challenge. In the last few presentations I made toward the end of 2024, I was kind of making an appeal to people that if you are aware of this applications of additive electronics out in the marketplace, please tell us. We'd love to share that story with our members and with the general community. But it is happening.
Okay, so can you outline just sort of what the concept of hybrid electronics or hybrid flexible electronics is? Sort of, you've mentioned additive, it being additive. Can you just sort of paint
Yeah.
a picture for what this particular technology looks like?
Yeah. When we started, NextFlex been around, by the way, happy anniversary, NextFlex. We've been around 10 years, starting this summer. When we started, we had a very, I'd say, specific view of what this technology was going to look like. It was going to be printing interconnects, printing circuits, so additive in nature, but then also combining that with thin flexible die, or even the technology from Pragmatic as a great example, right? The reason I kind of tend to use the word additive more frequently lately is because we've also realized that it doesn't have to necessarily be flexible for it to be an important avenue for people advancing technology. So yeah, it can be flexible, which is great. And for some applications like clothing and things, stretchable and flexible is fantastic. But there's other applications where people just want to print things directly onto a surface. Maybe it's even a three-dimensional surface. And we can do that now, which is really cool. So it opens up yet even more application spaces, which is really fascinating.
Okay. So we'll get to Mark in a little bit, and Murata has sort of an example of what this could look like, the form it could take. But Josh, I wanted to turn to you to discuss what Pragmatic is focused on. It is developing what it calls flex ICs, and so can you sort of go through how those are different from traditional chips and sort of how you see them fitting into this sort of landscape of flexible electronics?
Yeah, sure. Well, I mean, just to echo some of the things that Art was saying, that actually, there's a lot of emerging trends that are looking at really kind of challenging form factors, which, are challenging electronics, which, putting it in places that we have done before. And so I think from a flexible electronics perspective, there's a drive to be making the electronics more complex, or flexible electronics more complex. But at the same time, from the semiconductor industry, there's a strive for cost optimization, kind of agility in development cycles, and those things kind of coming together really is where I think Pragmatic plays a role. And so you're absolutely right. We call our technology flex ICs, and that's flexible integrated circuits. And this is kind of bringing that kind of balance of the complexity of effectively kind of semiconductor design, and bringing those together in a flexible form factor, allowing you to kind of get the benefits of both worlds, right? And so you get the form factor benefits of the flexibility. Often the thinness is really interesting, of course, for a variety of customers. But we manufacture that using kind of traditional semiconductor tools. So we get the opportunities to manufacture at scale, and we do that on 300mm wafers, in which the industry, particularly the semiconductor industry, is very familiar with. And so it's we think that our technology is quite an interesting kind of pinch of those two worlds kind of coming together, which historically maybe hasn't always been the case.
So I wanted to turn to Jing Chen next and ask if you could maybe sort of review where these types of technologies are used today, and if you can, why engineers turn to them.
Right. I think we definitely see more flexible electronics applications with diverse applications nowadays, and moving beyond just those simple bendable circuits to really incorporate with the highly stretchable and also conformable designs. For example, I think wearable electronics, such as earbud, is a good example where designers really need to embed all those electronic components, such as batteries, PCBs, in such compact device, right? And flex PCBs make it possible for not only fitting all those components in such devices, but also to be conformable to the device shape. And other applications such as foldable and conformable displays, which are widely used in those foldable smartphones, and also the augmented reality and the virtual reality headsets with those curved display surfaces. And another application I can think of is medical and healthcare applications, such as those implantable sensors and also the really flexible electronic skin even. And I believe flexible electronics can definitely bring a lot of benefits to different perspectives, such as from industrial design perspective, with much smaller form factors, all the sizes and also the materials used in flexible electronics are significantly reduced. And that really can help with reducing the manufacturing cost overall. And from users' perspective, the user experiences are greatly improved because of the flexibility, portability, and also the convenience brought by those flexible electronics as well. And at the same time, the functionalities of those flexible electronics are keep increasing.
Okay, so I wanted to turn to you, Mark, to answer this next question or to get us started in talking about it. But when these more advanced forms of flexible electronics that are, bendable, stretchable as the case may be, which I'm sure you will get into, become ready for widespread use, what do you think engineers will be able to use them for? And maybe as part of that, what won't they be able to use them for? Where will traditional electronics sort of hold fast?
Well, great. Thank you, James. Yeah, I think from our perspective, when we look back at just history, PCBs from the 40s and then flexible printed circuits from, I think, in the 70s, right? And now we're in the 2020 era. I think, flexible electronics have been around for a while, given that history. But now, from our perspective, now we're offering a stretchable printed circuit. So it's in addition to the flexibility, the stretchability. So I think as some other members have mentioned, we really think areas where challenges have been in the past are really around the human body. I think, the four Ps for data-driven medicine, it's prediction, prevention, personalization, and participation. To do all four of those well, especially participation, you need materials that can be body worn, that are comfortable to wear, right? So that when something's on, somebody's not worried about it, they can go on about their day. You can mount components to them, they're conformable, and in addition, they have to be stretchable. So I think that in itself can lead engineers to think of other applications, but I think the body is the most unique, you know, um, element structure that you have to work with, right? And that's still something where I think there's a lot of futuristic opportunities. But that's one I think around body worn opportunities. And that can translate over then into textiles and other things as well. But a lot of our focus is going to be on the biopotential medical wearable space, trying to get rid of a lot of cabling the best we can and try to drive a lot of that to stretchable electronics. But then I think engineers will have to be mindful of, now there's dealing with different mechanical properties to electrical properties, right? So you have the rigidness of a flexible PCB in some ways, but then you give up some of the electrical performance when you go to the stretchable. So those things have to be considered. So I think the engineers will have to understand modeling and some other effects, like electrical resistance, for example, in those applications.